Hello, everyone. Spectre, clean up the first. Is that 50? I thought you were at 49. Yeah, that's 50. Yeah, we really need a make your channel points prime routine. If there's a way for me to actually like calculate that automatically, that'd be kind of funny. Uh, it would be weird. I could think of a way to do that though. YouTube streamer, are you gonna go live at any point? Oh my god, oh no. 1 second, everyone. I was clicked into the gaming channel. Ugh. Okay, I am live on the proper channel. Let me just get the proper YouTube chat up on my screen. There we go. Okay. Dominion card. Oh, okay. Man, that sucks that the ads are messing with it. I wish that didn't happen. I'd rather just not have ads on the stream in the first place, but Twitch, if you want to be affiliate, then Twitch forces ads in some form on you. Yeah, Spectre, I owe you. Okay. I've been working on this single E&M problem basically for the entire week of this math streaming. I really want to finish it. Back to studying you go. Good luck. Godspeed. But a house today? Oh, you just bought a house? You refuse to surrender to Spectre? Well, I mean, congratulations on the house. That's awesome. That's the real prize. Gotta sell it for the sub. Yeah. Think of how many subs that the house could buy you. Jello and mayo salad. Wait, are those two separate things? Is it one thing of Jello and one thing of mayo salad, whatever that is, or is that literally Jello with mayo? That feels like a real thing. Also, I want. I think this might be my favorite color for the lights. Jello salad includes mayonnaise. Okay, yeah, that reminded me of like one of those things that like people like used to bring to stuff like that. Hey, 750, how's it going? 30. Wait, I'm trying to count the zeros in that. 32 million divided. Wait, no, 3,200,000. Yeah, okay, 3,200,000 divided by 90. That's how much you can get. Oh yeah, that's right. There was like a whole like thing where like Jello everything at one point was like a popular dish. I'm kind of glad that I missed that because it doesn't seem good. You have an announcement? What's that? Global maximum continuously differentiable bounded non-negative function over a compact set of all human capabilities. Oh, thank you, 750. That's a hilarious compliment. Okay. Um, what am I doing? In the L goes to 0 limit, verify the solution correct reduces to the solution for an RC circuit. So is L going to 0 the same thing as R going to infinity? Nearly, but here we have r squared, here we have just L. So it might be, well, Taylor series. Let's do the Taylor series. Let's not do, you know, the stupid math way of whatchamacallit, L'Hopital's rule and doing things the right way. Let's just use a Taylor series and only use the first two terms and just not worry about it. So root 1 minus epsilon is about 1 minus epsilon over 2. And this is our epsilon. That becomes a 2. Wait, it was epsilon over 2, right? Yeah. Sadly, Love Show side or joke side with LD has been shot down due to server errors. The computer we're using stored data was burned due to clock accident. We're very sorry to our listeners and joke shares. We will announce if we get back to it. Damn. I'm gonna miss LD's joke show. Rest in peace. If you wanted 3 terms, you'd use the McLaurin series since it has 3 syllables. True, Phobos. But clearly a McLaurin series is better than a Taylor series for that reason. 87 gigabytes of text gone. That's a lot of text. You're alone. Oh yeah, it's in 6 days. I mean, you're alone, but you're not alone because a lot of people are too, including me. So we could be alone together. There you go. See, join the club. It's great. Beta 1. Honestly, in general, I do not care about holidays. They're a nice excuse to get together with family, and other than that, like, meh. Laurent greater than McLaurin. Play Cyberpunk all day. Hey, yeah. That's something. As oh my god. L goes to 0 is the one we're concerned with. Beta 1 goes to, let me just make sure that. Okay, yeah. Just checking something. Oh, back to purple. All right. So beta 1 is plus. So it's 2. So it'll be 2 times this for the first term, which blows up to infinity. And then we do that times that, where the L's cancel. And so it's just going to be infinity plus or minus a constant. So beta 1's going to infinity. Beta 2, here we have a minus. So it's, these ones cancel. That becomes a positive. We have that times that. Which is actually 1 over RC, which is perfect. So then if V of t is equal to AE to the minus of beta 1t plus B, that's a terrible B. BE to the minus beta 2t. Beta 1 is going to infinity. And so e to a very large negative number is 0. Beta 2 becomes minus 1 over RC times time. Oh, and look at that. That's just the equation for voltage in an RC circuit. So that's interesting. You can either take resistance to infinity, or at least very large, or L to 0 and get a similar result. Which makes sense. I guess this is if you go R to infinity, you have the justification is there's very little current, and so the inductor doesn't have much to induct on. In non-physicsy terms. Whereas in this, you're basically removing the inductor altogether. So there you have it. It's getting ready to ping on my Discord. Okay, and the C goes to infinity limit, or double zero, as some like to call it. Verify the solution in 8.15 correctly reduces to an RL circuit. Hey Rex, how's it going? Shots fired? In a good way, you know? It's double zero. We have a W, why not a double zero? I think we're missing out. If capacitance goes up to infinity. If the I'm trying to figure out the physical meaning of infinite capacitance. Capacitance is charge per volt. You're getting a lot of charge for a little volt. I don't know. How about an 8 sideways? Yeah, that's also true, yeah. Drumcat is here to be entertained. Well, Drumcat came to the wrong place, but hi, Fembox. I'm doing good too, Rex. Thanks for asking. I've been working on this one E&M problem for like a week, but there's been enough like math questions that people have been asking to keep me busy. So they'll actually get through, and then I'm probably gonna get back to mechanics. Hot take: we should switch to Trunic. I never heard of Trunic. What is that? Reading group on circuit theory, electrical networks. That'd be cool. I mean, I'm legitimately interested in it now. The language from Tunic. Oh, Jed was just asking me to take a look at that game. I only looked at like briefly though. It's like a puzzle game where you play like a little fox dude. You know, I definitely am enjoying it. As that's something I'd like to study. I don't know if I'm gonna be able to prioritize it though, because right now I'm still in the train of wanting to get through mechanics so I can do general relativity. I also really need to get better at linear algebra, so that's like kind of close behind. And also the other things that I posted that I want to study in the reading group channel are also just like cool to me. I don't know. I would enjoy learning more about circuits, but that one probably isn't super likely for me anytime soon, unfortunately, even though I would like it to be. If there's maybe like something small, like a book that's like similar to like DivGrad Curl in terms of like the length, that could be possible, I guess. It's another less you know, the better Zelda clone. And when you say clone, okay. That's cool. You like the puzzle game that we plays? Oh yeah. Lorelei and the Laser Eyes. One of the catchiest names that a game has had. You know, I should add Tunic on my wish list. Maybe if it goes on sale, I'll pick it up. Here we go. C going to infinity. What is R over? Is that an RL circuit? Is that the same thing? Or what's the result for an RL circuit? Wait. Yeah, this is instrumental study playlist. I feel like I should get a variety of playlists in there. I should think of more genres to look up that are like good for it. I do like synthwave in general for like some instrumental music, but the playlists kind of get, or like it can get a little like samey. I remember it's if solving the current is basically the same as solving for the voltage, but how do you go from the current to the voltage again? Is it as simple as Ohm's law? Maybe you need Ohm's law for AC circuits. I forget. They were talking about this. Maybe it's these equations. So we integrate it, or maybe these equations. Hmm. Ah, fuck it. Who cares? Let's just solve the actual problem. I just wanted to be told the answer. I don't want to have to work it out for myself. I just for like if this actually does match with the voltage in an RL circuit, but oh wait, should I be looking at? Well, no, never mind. I don't know. Are inductors only interesting in AC circuits? I assume they don't have much of an effect in a DC circuit because the current is gonna level out pretty quickly and not change. Yeah. Okay, I was just wondering if I could find the solution in like a previous like chapter entirely, but probably not. Um. Oh, wait, they say. Oh my god, I need to learn to read. Ugh. Uh. If C goes to, so I think we're taking the same beta 1, beta 2 thing, and just taking a different limit now. Actually, let's even take the same approximation. Because this is physics. We don't do L'Hopitals here. L'Hopitals is not allowed. As C goes to infinity, beta 1 goes to get R over L, don't we? Because this R over 2L gets multiplied by this 2. And then I don't care how the cancellations from here to here work. I just see we have a C in the denominator that's going to go to infinity. So that's going to zero out. So then for beta 2, we're going 0, right? Because the ones inside cancel. C is going to infinity. Yeah, and the C stays there. So that's going to 0. Okay, and so now the voltage that we get is AE to the minus R over LT plus B times E to the 0, which is 1. And that's the constant they're talking about. And so if the capacitance is infinite, we're kind of back to figuring out what that means. Is it providing basically a constant voltage? Is that what's happening? Because B is a voltage. Have you seen Kanye's latest crash outs? I have, but that I don't want to go there. Okay, so if you, this is an RL circuit, but you throw in an infinite capacitance capacitor, what are you accomplishing? Capacitors, this is something Fenbox told me. I hope I'm remembering it the right way around. Capacitors maintain voltage by changing the current, whereas inductors maintain current by changing the voltage. So if a capacitor is maintaining the voltage, I wonder why Faraday gets capacitors and not inductors. I assume there's a historical reason there. But wasn't his big thing inductance? No. Hey, Laylee. Do I stream studying math? I want to see how to study it exactly and how to understand math literature. I do also stream math studying. So right now, the thing that I haven't been studying is analysis because of Zach's class, E to the 2a pi. If you're asking about like academic papers, though, I pretty much never study those, like on stream or off stream. If you're interested in specifically reading about math literature, I feel like Zach would be a good person to ask, and also Ian Stuckey are two people who like come to mind, who often have thoughts on how papers like that should be written and like how the user reader can interpret them. If you have a particular paper you want to talk about or something, I'd be happy to like take a whack at it, but I'm not super confident. I just don't have a lot of like background to understand it. But in general, I kind of just mess around with something until I feel like I understand it. I very much like learn by doing. So most of my general math books. Oh, okay. Oh wait, Femlux, or the current through an inductor has to be a continuous function, voltage across capacitor must also be continuous. Okay. Um. Hmm. It's a good question. I'm not going through a particular math book right now, unfortunately. Uh. Hey, Cook. I know. I'm trying to think of like what I can do for you, or at least like Hmm. It's just messing around that most people say they do when studying math. What does that look like? Do you develop your own way of learning? Um, hey Ben, I studied applied math in minor in computer science. Take a break after reading everything, do some practice problems, move on. Yeah, Hamish, definitely that hands-on practice is really valuable. Um, yeah, it's a little bit of somewhat of like a I guess like a personal thing where like different things work for different people. You know what? I think there is a question that I can think of from the analysis class that is in the spirit of what you're asking about. Let me try and find it. Because it was about interpreting a definition that I'm familiar with, but the definition comes from a different context. Um, Basically, like you, it involves trying to think of examples of things that would involve whatever you're reading and like try to like break it or think of things that might not work for it. It's kind of how I often frame it. Okay, so I think I found it. It's from meeting 10. This one. I have never seen this definition before. I remember that it existed, but let's see if I can look at this question and wrap my brain around it. Just give me a second to get some screenshots. Hey, Le Chiffre? I'm probably pronouncing that wrong. You're a legend in my mind? Oh, well, thank you. I definitely don't feel like a legend, but I appreciate it. Typo. It's been known to happen, but before I can't see it yet, but let's go into the definition from the opening part. Wait, okay, so this is for uniform convergence. Let me grab the one we were given for uniform convergence. Okay, so the definition of uniform convergence that we've been working with um, is this one up here. And so the important kind of feature of, or the thing that makes it uniform is that you can make a choice of big N that does not depend on X. If it doesn't depend on X, then you have pointwise convergence, which is kind of like weaker. Oh, you're saying this p should be less than epsilon. That's probably that seems like it makes sense considering that that's a pretty common thing. But let me read through this too and understand it for myself. So this is an alternative. This is like a bonus question, just learning about an alternative definition of uniform convergence. And so let's see if I can figure out what this means. A sequence of functions f sub n of x converges to f of x uniformly in an interval I if given a random epsilon greater than 0. There exists a natural number n where if small n is greater than big N of epsilon, then the supremum, the absolute value, that's a good question. Lately, I should have. I'll bring in the other definition too. 1 second. So we've been learning about two different kinds of convergence in this class. The first one, pointwise, or like the other kind is called pointwise, and these two definitions are nearly the same thing. The most significant difference is what big N is a function of. And you kind of want things to converge uniformly. They're just kind of nice. Like they have a lot more like properties that are helpful. Of course, not everything does, but that's kind of how I think of these two things. And the difference between them, like often continuity is what breaks this. So like if the function is say f of x, like the function here that we're saying we're converging to, if we look at say f of x equals 0 for x on 0, 1, and 1 for x is exactly 1, we'd have a function that is almost always 0. But then right at x equals 1, it jumps up here. And you could make a function or a sequence of functions that converges towards this. You would say f sub n of x equals x to the n. And so the idea is these are polynomials. Like if n equals 1, you just have a line. If n equals 2, you have a parabola. And if n equals 3, you have a cubic, and that's a little bit flatter. N equals 4, it gets basically like flatter and flatter, and it starts to look more and more like that function is the idea as n increases. The reason that if you want to, the point of this is that over the entire 0, 1 interval, the best you can do is prove this thing is pointwise, because your choice of n is going to depend on x because of this jump here. It causes issues. And I think it's not always the case that you need a jump to cause issues. It's just that's like a very common thing. You can show uniform convergence over any interval that doesn't include 1. So say like 0 to 0.75 or something. You can show uniform convergence over that because there's nothing weird happening. But over the entire interval, the best you can do is pointwise. Hey, Joseph. What is that emote? Stirring the pot. So this isn't something that I'm completely like solid on for myself, but that's sort of the idea of these different kinds of convergence. And then we're looking particularly at uniform convergence in number 8 here. So sequence of functions f sub n of x converges uniformly to f of x uniformly in interval I if given a random epsilon greater than 0, there exists a natural number n, or if n is greater than big N of epsilon, the supremum of the difference. Have you worked on any of the unsolved math conjectures? No, Orange Hue. I don't have the confidence for that. I can't even like name them. Like I assume like the Colette conjecture might be included in what you're asking about, but I can't name any others. I don't understand what big N represents in the definition, so I'm getting stuck while studying. Where do you turn to for those small questions, or you just ignore as it become clear later on? Yeah, maybe this isn't. I also feel like I should choose something that's completely foreign to me because this I already have some background on. When something like that comes up, honestly, personally, I just kind of try to plow through it at first and read the rest of it and see if that helps it fall into place. I don't imagine that would be very helpful here. And so in that case, you either like just name any example of hey Cruz. I would just name any example of a sequence of functions, what you think it converges to, and then try to apply the definition and see if you can make sense of it through that. And failing that, then I would turn to like Google and like look for a Stack Exchange thread or something. Le Chiffre, I do not have a master's or a PhD. I just have a bachelor's. Got stuck for 3 hours and 2 math problems today. My head hurts. Oh no, Lucas. I saw you ask Zach like you had some really funky logarithm questions for Zach. Yeah, those look super weird. Yeah, Lily, I wonder if I should just like find something like from a linear algebra book or something that's going to be really foreign to me. I could try. I might have something offhand on my computer that I can look through. Let me look at Cruz's question here because I think it's gonna be a quick one. Yes, I hope it's gonna be a quick one. Let's find out. Limit as x goes to 0, ln. Oh, wait. Cruz, is it like this? Yes? Okay. Orange Hue, a sequence of functions is like, I put an example over here. So like f1 would be x to the 1, f2 would be x to the 2, and like so on like that. And if you let n go to infinity, you eventually get this like step function here. Okay, so if we try plugging in 0 directly, okay, I think it's going to be L'Hopital's. If we were to plug in 0 directly, we would get ln of 1 over 0, ln of 1 is 0. So this is indeterminate. We're allowed to use L'Hopitals now. And so I'm going to take the derivative of the top and bottom. So the top becomes 1 over 1 plus x squared times 2x over 2x. Let's clean this up, I guess. We have 2x divided by 2x, so those cancel. Oh, I made that infinity. Oops. So we just end up with 1 over 1 plus x squared. Okay, here. And now we can plug in 0, and we just get 1. So I agree, that limit does equal 1 cruz. Piggy Master? 1011, thank you for the follow. Okay, so let me look. Do I, what do I have that would be completely new to me? Or at least, like, pretty new. Oh, you're Papadoria? Oh my gosh. Well, welcome over to the Twitch side. The infamous Papadoria with the very difficult questions and the disguised Colette's conjectures. Hey, Kuzaima. To differentiate from a 2D equivalent, f of xy equals x to the y? Almost, but y is discrete. Like, y is an integer. You probably could, there probably is a multivariable angle you could consider it from, but usually you consider them kind of separately. Or like you just like, you come at them from a different like angle. Okay, I at some point someone must have recommended this textbook to someone because I have this on my hard drive. Let me just look for a random definition I haven't seen before. Why? What? The author and its cat Moon with the Golden Gate Bridge? What? How much convincing did he have to do to get the publisher to include this photo? Like, what? He's like sitting in his chair too. I think he took this picture from a webcam. Oh my god. It's hilarious. Digression on fields. Oh, okay, that's like a one paragraph digression. This is another chat on the YouTube stream, so at some point I was like, why not log on Twitch? Yeah. To be honest, I do consider Twitch my kind of primary platform. I just dual stream to YouTube because there's not a high cost in it, and I think it's good to do. But I tend to focus more on Twitch. Because so over the Twitch chat, Lately Saley asked kind of how do I study math that's new to me, as in like kind of understanding things that I'd never seen before. And so I'm trying to look for an example of something I'd never seen before and do my best to break it down and understand what it's talking about. And so linear algebra is a pretty good place for me to do that because my linear algebra could be a lot better. But these I've seen, I might need to get more advanced a little bit. I just don't want to get too advanced because then I'm not going to have a chance. Okay, maybe this might be a good target. This probably won't be anything extraordinarily difficult, but can we understand what a sum of subspaces is? Oops. Cruz. My original function was integral from 0 to infinity ln x squared over x squared times x plus root x? That's a weird integral. Like I'd be looking for like a comparison test or something with integrals to do that. You're actually about to drop another one? It wouldn't be a bad time. I want to try and think about this part first, and then for now you'll wait. Okay. Yeah, I mean, I can plug that into Wolfram Alpha quick. I don't have an immediate idea to integrate that for myself. Come on, Wolfram. It said 0 to infinity. Not there. Go there. ln 1 plus x squared over. Wolfram gets an answer? Really? I assume the x plus root x goes on the bottom. Oh, that's a funky answer. Something with pi? How does it do it? Oh my god. What is that? Indefinite integral? What is this? I... Ooh. I'm not so clear on this, Cruz. You have to eat. Okay, sounds good, Piggy Master. I can take a harder look at this in a minute, Cruz, if you want to talk about it more. But I want to see if I can break down a definition, like think about it a bit more, and then I can look at you next if you want. It's something simply to get an actual answer. Huh? Funny. Sometimes Wolfram does do things weird. Suppose V1 to Vm are all subspaces of V. Okay, first question, what the hell is V? It's probably just a vector space. I'm on page 19. Let's go back and look at V. Oh my. Why are they... I'm kind of curious why they're talking about this stuff. Okay. Define a vector space to be a set V with, in addition, a scalar multiplication on V that satisfy the properties in the paragraph above. The paragraph above. Motivation for a definition of vector space comes from the properties of addition and scalar multiplication in Fn, which I think is just a field, a generic field, which I'm not quite... I've heard of them, and I know slightly what they are, but not really. Addition is commutative, associative, and has an identity. Every element has an additive inverse. Scalar multiplication is associative. Scalar multiplication by 1 acts as expected. Addition and scalar multiplication are connected by distributive properties. Okay. In addition on set V, wait, what was what? I don't think the sound plays to YouTube, or does it? On Twitch, you can make a sound play that's George Takei going, oh my. I don't think that comes through on YouTube, though. It might. Honestly, I don't remember how I set that up. Fnx is not a sequence of functions if n is the number of cats on each country order alphabetically. Yeah, n has to be a natural number. Or number of cats on each country. Yeah, n can't be like some arbitrary thing, I guess. Yeah, I do have to make sure I don't play music on YouTube, because if you play music on YouTube, they like send a hitman after you, and I'd rather not have to deal with that. Scalar multiplication. Okay, so wait, was I not on page 19? Oh no, I'm putting me on page 9. Hey, Raven. Average YouTube, yeah. They take their copyright seriously. And Famous, I do see the Rubik's Cube solve. I really want to do this. And then um, I'll do that quick, and then I'll do Cruz's integral. Suppose V1 to Vm are subspaces of V. The sum V1 Vm is denoted by V1 plus dot dot plus Vm. It's a set of all possible sums of elements of V1 and Vm. Okay, so maybe we're adding... I do see below they have some examples of sums of subspaces, but before I look at those, let me try to play around with it for myself. And this is the playing around with that I think you're kind of like curious about. So I'm just going to take V1 to be, maybe we'll go, they have to be subspaces of the same vector space. So I'm going to maybe make my vectors 3 long. That's like 1, 0, 1, and 1, 2, 3. V2 can be -1, 10, 2. And then I guess we'll do a third one. I don't know, E. That's fun to put in a vector. 5 -2. I want to make this one have 3 elements. Why is it so hard to think of random numbers? Okay. And so I think the sum of these vector spaces, it should simply, well, are we taking scalar multiples of these or not? You know what? I also need to figure out what sense do they mean addition in. They probably mean like set addition, not like vector addition. Right, yeah. The scalar multiple part is built in. I'm looking at like this piece specifically, and I'm getting like, I'm sure they don't mean do... Wait, what the hell is this? Why is that one lowercase? Oh, wait, I get it. Okay, no, these are a pair and these are a pair. Okay, never mind. Where small v1 is any vector in the subspace v1. Okay. So they do not mean do like 1, 0, 1 plus like -1, 10, 2 necessarily. Like, that's not what this part is saying exactly. They're saying, you know, any scalar multiple A from V1 plus any scalar multiple B plus any scalar multiple C from V2. It's more like this, I think, is what they're saying. Is what is essentially going to be inside those brackets there. E5 minus 2. Yeah, so V1 comes from, or sorry, the first two vectors I listed here are all the vectors in the subspace V1. The second or the third term is all the vectors in subspace V2 in theory. And then I would have 3 more terms for V3. Raven, this is Haley asks, like, how do I study math, and kind of when I see something that's new to me, how do I think about it? And I didn't quite know how to explain it, so I just opened up a linear algebra textbook and looked for a definition that I'm not quite familiar with. So the thing I'm studying right now is linear algebra. I'm just kind of looking at this one definition here and trying to understand it for myself, basically. And then we have an integral to do, and I also have Rubik's Cube to solve after this. And then we're gonna probably have a tough question from another person once they're done eating. Oh no. That was like a leading question as I interpret it, Finlux. I don't mind that like at all. And so I think if we use the same notation as like here, the sum of the vector subspaces, it should just be all of these things in a list, I think. Now I do have a question, which is, you know, just from things I do know in linear algebra, these vectors are clearly not linearly independent. Do we care about that when it comes to just an arbitrary subspace? I assume not. I assume this is as valid of a subspace as any else, but it is a little bit weird of a subspace. Like, why do we have 6 vectors in here? Yeah, Cruz, I use a tablet to write my math with. With V1 belongs to V1, VM. So once we're adding our elements of the subspaces. The program is called Journal++. I'll spell it out as it's spelled. Like that. Yeah, it's free. It's a pretty decent program, it looks like. All its elements for adding are elements to the subspaces. Yes. They're saying it's every possible... You know, maybe... It's every possible element from V1. I mean, it's kind of, you know, there actually is a little... I think that I have the right end result, but there's a little peculiarity in the wording, or at least in how this is presented, that maybe I should think about a bit more. Let me bring that stuff down here, because the thing I just was thinking about now is that if I do look at this like very strictly, V1 is any element I want from big V1, but it's only one of them, is it not? Is it actually... I feel like it's not a particular one, but like... I almost wish they maybe expanded on this pattern, because I could almost see this being like, if it's me if the next part of the progression is V2 belongs to V2, then that's weird to me. I that's kind of weird. It should be like, because that implies like we're only taking one element from each set. So like I would go immediately over to v2, and then I would. But even then, there is no v2 in v2. So I think that the progression must be like every element, like the next one is like v2 in v1, and the next one would be v3 in v1, and then now that we've exhausted, oh wait, we only had two vectors. So now we've exhausted the two vectors. Now we would move on to v2. And then we would move on to v3. So it's kind of weird. Just I almost wish they provided the next thing in the sequence, but I guess you don't know if v1 has more than one element. If x and y are in v1, then x plus y is also in v1, so you can take those two as one element. Well, wait. So maybe I'm thinking this wrong, Luber, but the span of x and y is not the same as the span of x plus y, right? Or wait, oh wait. Maybe no. I'm thinking about what you're saying wrong. Yeah, and so the thing that I'm talking about here is probably inconsequential if you're actually good with linear algebra because of what Lubert is saying. It's any element you want of V1, and V1 isn't just these two things I listed, it's any linear combination of those two things. So like I could also have validly put in this first one, say 2, 2, 4, what you get if you sum these two things up. And then whatever's next, I guess. Oh wait, actually, is this literally addition then? This might be actual addition. This has more depth than I thought, to be honest. First I was worried this might be too simple, but there's actually more to unpack here than I thought. I think this is just regular vector addition then. In order for your v's to be vector spaces, they have to be closed under vector addition and scalar multiplication to begin with. To me, you were just listing generators. Yeah, I mean, I know like this is going to be the result of this, or at least I'm pretty sure, and you can simplify this and get something equivalent, just like a span of R3, I'm sure. But I'm trying to take the definition a little more literally and like try to build towards the thing that I think we're going to get. You can have multiple elements of V1 in the sum. Yeah. Okay, and so I think maybe what this is doing is where this definition may be actually doing is it's taking every element of V1 and getting any combination with every element in every of the other and all the other subspaces. So this is actual like vector addition in here. Just done on every possible element. Let's say like 2e10 minus 4, just multiply like this one by 2. Like, and then you can do something else with these two if you want, or multiply them by 0, I guess. Okay. And so by doing this over every possible thing, you are basically, or like that's how you add these two subspaces. Like you add every possible element. Okay. So maybe now is a good time to look at the examples that they listed and see if what I'm saying here matches with what they're saying. Suppose, actually, I can keep the definition up there. Suppose U is a set of all numbers, or a set of all elements of F3, and I assume F is just a generic set. Like it could be real numbers, complex numbers, whatever you want. Functions. Whose second, and sorry, Orange, I saw you put something earlier and I didn't address it. I will look at it more after this though. Whose second and third coordinates equal 0. W is a set of all elements of F3 whose first and third coordinates equal 0. Okay. Then U plus W is literally just the vector addition of x0, 0 plus 0, y0. And I assume you could have equally as validly put like 2x comma y comma 0 or something like that too, and it'll be an equivalent subspace. Field, okay, yeah. Wait. Yes. I was just verifying in my head that this does include our original fields back. And it does, because if you wanted to get back to just U, you can just take y equals 0. Assuming 0 is allowed for y, but I would think so. And same with W, you could take 0 for x. Hey Colton, any problems? Yes. I'm kind of talking about some linear algebra for another couple minutes, and then I have an integral to do. And also, I want to explain something simply quick to Orange Hue. I might need to make a queue if you want to put something in there, though. It's okay if you do. There's something posted in the Discord already. Oh, that's what Saito's put. Okay, I'm just gonna leave that be. But yeah, feel free to post your question if you want, and I'll make a queue and I'll get to you when I can. Okay, so what's the other example they give here? U is the set of elements of F4 whose first two coordinates equal each other and whose third and fourth coordinates equal each other. Okay, x, x, y, y. There's a set of elements of F4 whose first three coordinates equal each other. Find a description of U plus W. Consider a typical element. Importantly, this x isn't necessarily the same as this x, I assume. Consider typical element A, B, B of U and typical element C, 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 D. Okay, right. They aren't necessarily the same because we're using different constants. Where A, B, C, D are all in F. Then the sum of those is that. And the first two coordinates are equal. And then the last two are not equal. So you get this type of definition. It's a subset. Oh, you have to prove it both directions? Oh my gosh. Okay. Equal each other. For like the coordinates, they're talking about things abstractly with fields, but you could pretend just for the sake of this that it's real numbers. So like a valid vector to put here is like, say, 2, 2, 0, 0. Or something like that. They're using F because the same thing could apply to like complex numbers or things I haven't heard of, like, or like functions or something like weird that I haven't studied. But I think for the sake of this discussion, we could just pretend this is R for real numbers. And so if you do add U plus W, you get a subspace where the first two coordinates are equal, but the last two aren't. You do have to prove inclusion the other direction, which I don't quite understand. U plus W is a subset of this. Suppose XYZ belong to F, then XXYZ is equal to XXYY plus 0, 0, 0, Z minus Y. The first vector on the right is in U, the second vector on the right is in W. Thus, XXYZ belongs to U plus W, showing inclusion 1.39 also holds in the opposite direction. Interesting. Thus, now you can say they're equal. Or now U plus W is equal to this subspace. Huh. I'm very curious why you can't just make that an equal sign immediately. I might need to like do some more, to figure it out, I probably need to do some more reading earlier on. But I guess, yeah, that's kind of like, if I'm studying like the right way and I'm not feeling lazy, that's how I try to treat things. Like I look at the definition and I try to name things, I try to name examples that would like either fit the definition or not fit the definition and explain why. Um, the example I chose, as it turns out, maybe could have been more informative, or I could have chosen better examples maybe. But that's kind of like maybe a typical way of trying to understand something when I'm studying on my own. Yeah, no problem. That was a really interesting like question. I'm glad this helped. Uh, Ontran, I might be pronouncing that wrong. How do you compute circle notations? I'm not sure what that means. I'm sorry. Could you maybe give like an example of a problem you're talking about? Oh, okay, there you go. Oh wait, Famish, are you still here? I owe you a Rubik's Cube solve. I'll type your name in chat in case. You maybe have to show on mute or something. Okay. Let me. Okay, so I need to get organized here with who's asking what. So, um, in Orange, if you're still here, let me know if you want to talk about a sequence of functions. Cruz, you're still here. Good. Thank you for your patience. Um. Okay, so then Cruz wants to ask about 0 to infinity ln 1 plus x squared over x squared x plus root x, which is, I don't have an immediate idea for. Are we talking about cycle notation? Oh, I might be able to do that. I'm a little bit rusty. Okay. And then I'll write orange hue sequence of functions in case they come back. Can I maybe quickly try to figure out Ontrons? I'm sorry I keep like pushing this one back, Cruz, but oh, you have a solution? Or yeah, that's what you get. Let me see. Oh, good, that's helpful. Wait. Oh, what the heck? I'm not sure why you're going directly to a limit. Posted one that I haven't seen. Oh, okay, yeah, I see that now. Hold on. Thank you for saying that. Um, okay. Shoot. Okay. I I'd like to quickly at least try with Entrons. Because either I can do it quickly or I can't do it, and I don't want to keep them waiting in the event that I can't do it. They have sigma. This is cycle notation. 1, 3, 4, 5, 6, 2, and R equals 1, 2, 3, 4, 5, 6. I think you normally write it without the commas, but too late now. The question is R squared sigma equals what? I think like the weird thing is you normally go right to left, I think. I should write this without the commas. It's messing with me. Right to left. You're at the commas too. Okay. And so, without simplifying anything, R squared sigma would be this. And what's the process for simplifying? We would go right to left. So I think, do we think about it as like, we start with 2 gets sent to 1, 1 isn't involved, 1 gets sent to 2? Like, is that what we do? I'm a little bit rusty on this. Hey, syntax. Damn it. There will be an integral up here, yeah. You're saying yes, Antron? Okay. So 2 gets sent to 1, 1 gets sent to 2, 2 gets sent to 3. So it might be 1, 3 is the first piece of the cycle notation. And then 3 gets sent to 4, 4 gets sent to 1, 1 gets sent to 2. Oops. But then we already did 2. So that's a cycle, I think. I really hope I'm doing this right. I'm a little bit sketchy. 6, I guess we would look at 6 now. 6 gets sent to 2. The answer professor gave me is 1, 2, 4. I'm doing this wrong then. Okay, I'm sorry. I hate... There's a couple of questions that are waiting and I have no idea how to prioritize it right now. I'm really sorry to everyone, really. This one just feels like a quick one, which is why I'm trying to do it quick, but I'm failing at that. You've got 1 to 1, but I'm also pretty rusty also, not sure if I'm mistaken. The answer from the professor is apparently this. Five fixes 1. 6, 4, 8 fixes 1. 1, 2, 3 sends 1 to 2. Yeah, okay, so it doesn't involve 1, doesn't involve 1. 1 goes to 2. 8 fixes 2. 4, 5, 6 fixes 2. 2, 7 sends 2 to 7. 1, 3 fixes 7. So it sends 1 to 7. So wait, was I doing it right? And why was I getting 1, 3, 2? Do I need to... Oh, maybe I'm doing it in the wrong order? Wait. So if I instead think about 1 first, 1 gets sent to 3, doesn't affect 3. 3 gets sent to 4. 4 gets sent to 1. Yeah, what the hell? That doesn't make sense. The integral is up there. That doesn't make sense. 2 goes to 1. 1 goes to 2. 2 goes... Wait. 2 goes to 1. 1 goes to 2. 2 goes to 3. 3 goes to 4. 4 goes to 1. 1 goes to 2. So that's a cycle? That's so weird. I think I'm doing this... Either the professor is wrong or I'm doing it wrong on trying to... And I'm not sure what. I don't feel confident enough to say that anything is right or wrong, though. I need to move on and do Cruz's integral here. So I'm sorry, but I'm not quite sure with that. It seems like there's potentially an issue there, but I'm not confident enough to actually say anything about it. Thank you for the question. Okay, Cruz, I'm very sorry for putting you off. I'm doing this now though, or I'm working on your integral now. So, it's fine. Okay, thank you. It looks like the integral you split up into 2 from 0 to 1, but then from 0 to infinity, which doesn't quite make sense to me. It should be from 1 to infinity, I would think. But then you're saying that this piece equals 1. It should be 1? Okay. And then you're taking the limit as x goes to 0 of this piece? I don't quite understand why you're going directed to taking limits here. It feels like we need to integrate before we can even think about a limit. But integrating this doesn't seem easy. Will Wolfram Alpha play nicer with an indefinite integral, I wonder? So I guess I'm not quite clear on what your technique is there, Cruz. I'm not sure that that works, or at least I'm not aware of why that works, doing a limit to get rid of the ln. I agree, I hate it too. I'm just not sure that that's an allowed step. Unless... So, I mean, this thing converges according to Wolfram Alpha. Is the question to get an actual number for this cruise? Or just if it converges or diverges? Converge or diverge? Okay. So I'd be looking for a comparison here. 100%. Um, we want to name an integral that is more than this thing that converges. The question is, what do we fill in? Um, 1 over x squared. Ooh, that's a good call. That might work. Can we justify this comparison? Oh, that's why you're taking the limit. Okay. Or that's why you're even like thinking about that in the first place. Uh yeah, because the limit as x goes to, I guess I'm going to consider 0 and infinity here. But I think at least for the infinity piece, I think this is going to 0. We would need to L'Hopital to really show it. But I think this increases faster than the top. Yeah, it's 0? Okay. ln x is less than x. Yeah. That's good enough for me. Um, and so basically what you're doing is you're taking um 1 over x squared, and at least for the infinity piece, multiplying it by a small number. And so I think that justifies the comparison that 1 over x squared is greater than that. Does this thing even converge though? I haven't checked that. It should. I feel like it should. We should check that though. Minus 1 over x from 0 to infinity. Oh wait, that diverges. No. I was thinking about it wrong. We do get infinity here though. Okay, so that's not a good comparison then. It's a good idea, but not the comparison we want. So what about like x plus root x? That doesn't seem easy to integrate. It might have the exact same issue too of going up to infinity. This one, I might want to put this into Desmos. And infinity should be fine as 0. Yes, I agree. ln 1 plus x squared. Just so we can get an idea of like how this thing even looks. Because the comparison seems tricky to figure out by hand. And it sure does look like 1 over x, but really close to 0. It's like just like for comparison, 1 over x is a good chunk bigger than that. 1 over x diverges, though, unfortunately. Is 1 over x cubed? Oh, not for all of it. Hmm. Actually, let me look more into the x plus root x idea. Okay, does this thing diverge, though? Oops, I didn't mean to do that. Ah. This is a tough one. No. It diverges. Huh. Tricky. Like, ln 1 plus x squared, that has to diverge, right? Is that even easy to integrate? I don't think it is. Maybe you can integrate it by parts. And yeah, integration by parts could probably work. No way this converges, though, right? No, it's pain? Really? It diverges, okay. Damn. Hey, bamboo fishies. Actuarial math? Oh, basically nothing. I had never studied it before, I'm sorry. If it's something that's like early enough that I can try to understand it immediately, then I'll be able to try. But unfortunately I haven't studied it. Um so wait, x cubed, the issue with x cubed is that oh, x cubed would diverge. It has the same issue. Thank you for the follow. Love the concept of your channel. Oh, thank you. If you do, whenever I see a new face, I do like to let them know that I'm not the only one who actually does this. There's a whole like little niche of people who do math help on Twitch, and there's like a at least a start to all the people who do it. So you don't have to do anything you don't want to do, but I just like to let people know that we exist out here. It's not just me. Um, whenever the absolute value of x, maybe. I think I do really like your idea. I think we do need to. Oops, that's not what I want. I want to do that. Uh, I I forgot about the idea that you had of splitting it up like this. I think this we really need we need to do. 1 to infinity. Because actually this piece, I think this piece is easy now. Because that one we could bound with 1 over x squared, right? For the same reason we said before. And this one converges now. It's just 1. So we proven this piece converges? Should be, yeah. And so now we only need to worry about this piece. Now I'm not saying this piece is easy, but I think it's easier now we don't have to deal with one end of infinity. What does ln 1 plus x squared look like again? Oh, well, that's not good for 0 to 1. It's kind of a cool graph, though. Wait, how is that true? For small values of x... Oh, maybe it could be. Okay. Yeah, no, why would it shoot off to infinity? Um... There must exist a function that shoots up to infinity like this, but still converges. Apparently. That's a weird function, though. Because, like, x squared or x cubed are gonna diverge, so it can't be something as simple as that. Maxi, the question is... we have this integral from 0 to infinity. Does it converge or diverge? So if you split up into 2 pieces from 0 to 1 and 1 to infinity, I can bound the second piece from 1 to infinity and prove that converges. The first piece is the issue, though. Electric Geek, quick question. Oh, yeah? I'm going to refund Famous's points. Because I didn't do their Rubik's Cube solve. So I'm trying to think of a bound for, I guess, this integral here, basically. According to Wolfram, it does converge. So unless Wolfram is smoking something, that we should be able to find a comparison. I'm just not sure what that is yet. Are there infinitely many primes that differ by 2? Yes. Next question. What level is that? I'm not sure. It's from Cruz in chat. I think she's just in a calculus class. Calc 2? Okay. Did Wolfram ever lie to you? Me? I guess not. It does do some weird things sometimes. It does get an actual number, though. So it shouldn't be lying about that, because it'll do it numerically, if nothing else. That's the indefinite. The definite integral, it somehow gets 1.71. Man, there's no way it should be this, but like... just to look at it. This would fit the bill between 0 and 1. There's no way this thing is going to converge, though, right? Electric Geek, another easy yes. The answer is always yes. Are you kidding me, Wolfram? You don't want to do the integral? It's your job. I don't want to do the integral. Bruh. Is it even integrable? Uh, if you call that integrable, I don't know. 2 plus 1 equals 4? Absolutely. Chat GPT time? Not for me. I mean, it'd be nice. Like, if it could prove divergence, I wouldn't mind that. And just say that Wolfram is crazy. But it gets close to 0, like, really quick. Like, what? Minus ln 1 plus x squared? No, what about just x? One plus 2 equals 4, that's why it's an... Yeah, that is Chat GPT. If terms of sequence approach 0, does it guarantee the corresponding sequence converges? No. Baklava, the opposite is true, where if the terms of sequence do not approach 0, the series must diverge. But the opposite, the thing that you say, is not true. If the sequence approaches 0, the series has a chance of converging, but it's not guaranteed. You need to do more testing. And that's just because series are weird. No worries. Um, we could give it the integral calculator. This usually has more realistic steps. Uh, 0 to infinity. Me too. It gets a similar funky thing. Does it get an actual number? Scrolling all the way over. That's the indefinite. Oh my, this is a disgusting integral. Hey, Zappin. Dude. Cruz has had some pretty difficult questions before. I feel like it's a pretty cracked Calc 2 class. Um, yeah, I would feel the same. This is a crazy question. There probably is some bound that exists. Like, I feel like, does it need to be Riemann integrable to do a comparison test with? Like, I feel like, oh, maybe it does. If the original question was at least from 1 to infinity, I think this question is fair enough. The 0 to infinity piece seems very difficult. Yeah, Cruz, I'm sorry. I might be out of ideas here. We don't need a number. We just need to prove it's getting. Yeah, that's what I'm thinking too, Cruz. If it. The fact that there is such a weird answer, I think Maxi is saying that the integral probably doesn't exist in the sense that you would learn in a Calc 2 class. Like the result. It doesn't seem easy to get an upper bound for the 0 to 1 piece either. Like, I'm not sure. uh, if the ratio test for a series gives a result of 1, why can't you conclude if it converges or diverges is just inconclusive? It is just inconclusive, as you say. It doesn't um, say either way uh, of convergence or divergence. And I think the reason why is it's like I think intuitively at least, I forget, there's probably a more like rigorous reason. Yeah, sure, Cruz. But kind of the ratio test relies on the idea of a geometric series. So for like a geometric series, a r to the n, r has to be less than 1 in order for it to converge. And in the same way, for the ratio test, you have a ratio of consecutive terms that has to be less than 1. So if it's equal to 1, it's right at that borderline point of where a geometric series would start to diverge. And that's why things get inconclusive, because you're right at that kind of dangerous boundary point. But the idea of the ratio test relies on geometric series. And that's why 1 is that kind of boundary point there. Um. Oh shoot, you did ask before, Piggy. Yeah, you'll be after this one, and I'll put Colden's question to later. Ln of 1 plus x squared is a positive number. Root x is a positive number. Okay. Two-part answer? Okay. This thing... Okay, so we have a condition that can't equal 0, sure. So x can't equal 0. This just uses 17 as a cutting off point, and that's fine too. It might be intentionally chosen, to be honest. You have a method for the integral, but actually stuck in a diverging term in the middle. Oh no, Colton, okay. When x goes to 0 of the entire thing. Looks like a Lopitals. 17 is the professor joke. Oh, okay. That's funny. Penn Center has the same thing. But with 17, it's his favorite prime. Uh, so as x goes to 0, the function looks like 1 over root x. Okay, I guess what they're saying. Uh, oh, now a limit comparison? I thought that's what we just showed, but we do get 1, so these two functions are like each other, but I thought that's what we just showed right there. Anyway. Oh, is it going to be... Huh. Okay, I can't read that piece, but I assume 1 over root x, that integral is going to be important. How does... Wait. Oh! Does that converge? From 0 to 1? Oh my god, that might be it. Wait. Sorry, I'll look at the answer, or I'll keep on looking through. But if this claim is true, which I'm not quite, I haven't. That justification is still a little sketchy about the less than or equal to. Hey, Boat, if I didn't just say that, I'm sorry. My mind's going to a million different places right now. But hi. It's 2 root x from 0 to 1. That's a convergent integral if I've ever seen one. So as long as you can justify the comparison, you would be in business. And I think that's what your professor is doing. Hey, demons. Okay, looks like you're agreeing. Welcome in. This is justification for the infinity piece, but we already talked about that. X cubed, I guess, works about as well. Or no, okay, never mind. The x cubed comes from somewhere else. No? Okay. X to the 2.9? Sure. I feel like you don't need that to justify it, but I think that's an infinite piece that I think we're already okay with. It's just the 0 to 1 piece that we weren't okay with. When I was 17, I split a very good integral. X is basically g of x plus f of x converge and fx converge. Okay. Using Lebesgue integrability or doing something invalid if they're evaluating the integral of an unbounded function, getting anything meaningful. Really? I mean, I agree. The fact that it goes up to infinity is, but I mean, 1 over root x is unbounded, and it evidently converges from 0 to 1. Flavornius. If an improper integral has an infinite discontinuity inside limits converges on one side but diverges on the other, does the whole thing converge or diverge? I think you would normally say converge. I'm sorry, diverge, Flavornius. Normally if you have a divergent piece, you say the entire thing is divergent. It has to be bounded on the domain to be Riemann integrable. Oh gosh. Did you integrate this? Okay, here, wait. Actually, this is I should bring it up in a different way. Because that was low resolution the way that I did it, and I know why. But I'll look at this in a second, Colded. For the piece that Maxi is saying, I can't say either way on that. Maybe there is something invalid, or maybe it just depends on how the exact definition of integrability or integrals that you're using in your class or your professor is. But for what your professor seems to expect you to do, oh my gosh, is use limits to justify the comparison with 1 over root x and show that that converges. which is kind of crazy to spot that. I don't know. Oh, so maybe the justification is that um, since the function behaves like 1 over root x close to 0, and 1 over root x converges, then you would say the original thing converges. I haven't actually seen that exact test before, which is cool to see. You need to open your third eye to spot it. Apparently you do. The only thing that would make me think that would lead me towards thinking about this is that we're having issues where 1 over x squared, and stuff like that diverge for 0 to 1. I should have tried going for a smaller exponent between 0 and 1, because then it flips up to the top and it's going to converge. Oh, Max, it actually, yeah, I'm sorry. Maybe the thing that the domain isn't, I think it's maybe what you're saying there. The domain is actually, the integral we're actually doing is limit as t goes, say, to 0 of t to 1. Would that be enough justification for you? This is just shorthand, but it's actually that limit. That is a fairly common thing to learn about in a calculus class. Yeah, demons. I think that's right. So it's very difficult to spot that, but I guess that's what you would have to spot there, Cruz. Ah, 1 second. I might need to move on to the next question, Cruz, but I hope that at least helps a little bit. I know it's not. It's just a really hard question. No worries. Thank you for it. It is cool. Klong, hey. We need to do more lockdown. That was a lot of fun, and the hand simulator too. They were both a lot of fun. Try to you. Any progress? So syntax, yes and no. We never tried to actually integrate it. The task was to prove convergence or divergence, and we did do that. Basically, Cole did over in the YouTube chat. Apparently, may have integrated it, and we're gonna look at that right now. Put x equal to t squared. Okay. And okay, you do properly. Wait. You get a t out front. Wait, isn't there an error here already though? The dx is equal to 2t dt. Unless you accounted for that with this, with the 1 plus t. Oh, you did. Okay, yeah. Okay, this is okay. And you have the 2 out front. Okay, this is good so far. I mean, good is relative, but that looks valid. You do partial fractions like integral calculator did. Oh my god. Some of these you put back. You're mixing the t's and the x's here. I assume these are still supposed to be t's though, because there's powers of 4. And so the first integral, you split it from 0 to 1 in 0 to 1 again? What? 1 minus infinity, x equals 1 over t. Oh, okay, so on the second integral, you did a sub x equals 1 over t. Okay, so we're maybe playing fast and loose with the choice of letters, but that's probably okay then. I'm not checking the actual steps in that piece, but that's why we get 0 to 1 again. And you split up into two, you split that second one up into another two integrals, okay. Oh, and you use a power series? Yeah. Oh my god. You probably have to, but you got that far as well? Wow, well, good job, syntax. That's not even easy to get that far. Yeah, this is a crazy integral. I respect you for doing this by hand, but by God, you probably shouldn't have. Didn't get power series due to convergence. I didn't get that trick. Oh, okay. It's posted in my Discord syntax and math discussion. On Discord, their name is Delta. So for the second integral, you have to use another power series. I'm not checking all of these. I'm just kind of looking at what your techniques were. It seems like a similar technique for all of these. Then a mistake on the fourth integral was out of radius of convergence. Oh, okay. Apparently there's a mistake in I4 here. But hey, respect. So maybe that's why you got the diverging thing. Maybe you need a different technique for that one. I don't want to look for it, but maybe that's why you get a weird thing. Hey, Point Gallus. It's apparently convergent. We're just about to wrap this one up, but if you give the original thing to Wolfram, it gets an actual number. It was just a whole thing, but you can maybe what I wrote here is a little bit inaccurate. It's more like estimates. If you split the integral up from 0 to 1 and 1 to infinity, the 1 to infinity bit is relatively straightforward. You can bound with 1 over x squared. The 0 to 1 piece we're having a terrible time with, but you can apparently show that around 0, it behaves approximately like 1 over root x, and that converges. Which I haven't seen before with an integral, but that definitely exists with series. And I didn't realize that was a thing. So that was cool to learn about. Okay. No, I mean, Poingout's saying it diverges, but I think it converges. The answer that Chris's professor gave is convergence, at least, and Wolfram Alpha gets an actual number, which means it converges. So unless you can disprove those things, which maybe is possible, but all signs are pointing towards convergence. Okay, Orange Shoe, I don't know if you're still here. Speak up if not, but I'm gonna, or if you are, speak up if you're not here. Yeah, that makes sense. Maybe we should go over to Colded's question, I think. Oh gosh, I saw some. I forget who this person is, but BB posted some questions in Discord. It's gonna get piled onto the queue, I guess. I forget who BB is, what their username is, but uh Bumble Dog, yeah, go ahead. If it's a quick one, I'll just do it on the spot. If it's gonna be a little more involved, I might need to put you in the queue though. Um, which right now, oops, right now you'll be like third in line. But yeah, let me know what your question is. You can type it out there in the YouTube chat, or if it's easier to take a screenshot, you can do that and put it in my Discord. Um, we have 3 points, P, Q, and R in 3D. Find the value of the absolute value of 2L squared plus AB if L is the maximum of QP plus PR over QR, where A and B are real numbers. A. So this is like a plane, is it not? And we have 2 points that we're trying to find the maximum distance. Well, ooh, I don't quite know what's in the maximum here. The answer is 19. Okay, thank you for saying that. Uh, the best things either math homework help, like make a thread here, or do math discussion. Either of those two work. Okay, so that's the answer. 1, 1, 0, 6, 4. So if A equals X and B equals Y, and the third one is Z, this looks a whole lot like the, oops, I'm already wrong. This looks like a whole lot like the plane Z equals 2 minus X minus Y. And so QP, now what exactly is QP? QP is, it's a constant, the length of that line, plus PR, the distance from the point to the plane, over QR, the distance from the other point to the plane. Blood Thief? I never heard of it. Demo is free? Okay. Interesting. That's a weird quantity to have to maximize. Math discussion channel. Okay. 6 maps out and just a demo? Wow, and you're rank 6? Nice. Gotta snap up those high ranks while the game is still fresh. Oh, okay, yeah. This is a quick question. Let me go and do this one quick. Okay, there are some things with function transformations that I'm sometimes a little bit sketchy with, but let's see if I can do this right on the first try. So the first part, move 7 units left. How you accomplish that is wherever you see an X, you put in some parentheses. And if you want to go left, you do subtraction. Inconsistent notation, like here with the X's? Or I don't know. Is that right? Move 7 units left. Yeah, I'm pretty sure that's right. Wait, to the left. Yes. Okay, you know what? I'm going to Desmos, so I don't want to tell you the wrong thing. There's rules that you can memorize, but I never do. I definitely do not want to tell you the wrong thing here, though. Oh no, that's to the right? Bruh. Okay, I'm bad. It's plus. I'm sorry. That's so annoying. Yeah, it is the opposite for X and Y. Um, I think if you wanted to move it up by 7, you would do a no. Yes? Dude, okay. We're Why am I so bad at function transformations? Okay. You know what? If you don't know about it already, Desmos.com is a lifesaver for these types of questions. So we started with x cubed. We want to shift it to the right by 7. So we did a plus 7. Excuse me. To the left. Wait, what? Why is it on the left now? Wait, no. Okay, that is right. It is plus 7. Dude, I'm crazy. Okay, it is plus 7. Ugh, okay. Sorry, my mind's all over the place. Moving the grid by plus 7. Okay, that's a better way of thinking about it, because I'm trying to move the function itself. But yeah, moving the grid by plus 7 is much more intuitive. Now, for horizontal expansion times 3, since we're going horizontally, we want to multiply the x, but I think we want parentheses again around the plus part, and we would put a 3 outside here. Oh, I think that's a contraction. Damn it. That's an expansion. Why do we flip it? Look at where it would be 0. That's a good trick too. And then a vertical expansion times 5. Please tell me you just multiply by 5 on the outside, like outside of the cubed part. Okay, yes. This should be a vertical expansion because, like, just track, like, say, the function right there. It's now higher up than where it was before. Like, it went from flat to, like, higher up. So this one is nice because it's a really, like, visual thing, but I hate memorizing these steps and, like, what you flip and what you don't flip. So I kind of have to, like, play around with it like you just saw. The most important thing is remember your parentheses, though, and kind of where things go. So, like, anytime you do something involving y, it should kind of go on, like, the very outside. So, like, if you're happening outside the function, you're transforming the function. If it's inside, yeah, exactly. So, like, Maxi is just put it right there in chat. If you want to transform, like, x, or, like, transform horizontally, you want to work inside the parentheses, or, like, inside the functions. If you want to transform vertically or transforming y, you work outside. Yeah, Famish, because you just weren't here at the time, and so I felt bad. If you want to redeem it again, I'll do the solve. I just didn't want you to miss it. You thought the 1/3 would go with the x, so feel free to redeem it again. Sorry that I missed it. So you're asking why can't the 1/3 go here? And that's because, as we just saw, it shifts it even more. Like, it messes with the original shift. We only want it to be moved 7 units to the left. So that's why the parentheses there are important. For actually why I don't have a built-in, like, explanation. And simply split between Warby is a better one, but these function transformations are always a little sketchy in my head for what the rules are. Okay, let's... Yeah, no worries, Bombo Dog. Okay, thank you for the question, by the way. Okay, so... Hey, Solenia, it's going good. How about you? I'm going to do the Rubik's Cube. I'm going to solve the Minesweeper. No guess? What would no guessing mean? And then we're going to do this question from Colded. And then I think the only thing left. Oh yeah, we have a question in Discord from BB, and then a question from Papadoria, and I've already forgot Papadoria's Twitch name. Um, but okay, Rubik's Cube, Minesweeper potentially with Maxie's constraint. Um, oh, that sounds amazing. Yeah, Minesweeper dot online. Okay, I'll do that. Let me scramble the Rubik's Cube. I hate the guessing in Minesweeper. Okay, inspecting. Oh god, this is gonna be terrible. I'm not seeing it. Ah. Fingers are cold. This is a terrible solve. My fingers are way too cold. Yeah, terrible. But there you go. My best time? Yeah, I did CFO OP. Best time is 17 seconds. I got really lucky though. My average is more like 25. Um, Minesweeper dot online. No guessing mode. Hell yeah. We'll bump it up to medium. A chess stream? I kind of rage at chess. I don't know. I'm not very good at it. Am I supposed to click the X? Let's do it. Sudoku? I know the basic method. Need to start on the X. Oh, okay. I haven't done a Sudoku in a very long time. I only know the basic method of solving them. I actually way prefer this. This might be my uh regular Minesweeper thing when people redeem that then. Because the guessing sucks. It's the worst part of Minesweeper. It's already not a very good game in the first place. But the guessing just makes it like not even a game, to be honest. There we go. 58 seconds? I'll take it. Art of Cracking. I've been recommended his videos. I never actually watched one though. F2 pauses? Oh, F2L? Yeah, my F2L is I remember it's like one or two of the algorithms, but I mostly just do it by feel. People stream who are 800 on chess.com? I'm kind of surprised. I feel like you should be good at, or not you should be good, but it helps if you're good at chess if you're gonna stream it. Because at the end of the day, it's just no fun to stream to no one. Talk about backseating to a chess stream. Oh yeah, Squirt. So I also that's another thing. That's the reason I don't like playing chess is because I don't want people to help me because it is just cheating. And that also takes away some of the enjoyment out of a chess stream. It's like I do want to discuss the position with people, but it's just cheating if you do during the game at least. Brogan says chess stream in a bit wouldn't be a bad idea. Oh yeah. Um, I want to get a handle on where this plane is and where these points are. I'm going to use a grapher, aka Desmos. Six four four. I always stream math on both YouTube and Twitch. Um, I do also stream games, which is only on Twitch. Ooh, the first point is on the plane. Huh. Yeah, Fembox, we just... Alright, I just found the same thing. Okay. It is any point on the plane, though. It's not... It doesn't have to be the shortest point. Or, like, the shortest distance. Oh, hey. Thanks for switching over. Bombo Dog / Chaotic Diamond and the follow. Um... I feel bad, so not many resources for it on YouTube, but on Twitch, there's a whole like niche of math streamers out there. There is one person who, Actual Education does dual stream to YouTube also. Oh, please don't I have a command set up to link to his channel? Do I on YouTube? YT Math? Does that still? Yes. Okay. I should use this more over on the YouTube side. Oh, is it? Okay, that command for whatever reason it isn't working. But um, Actual Education does dual stream to YouTube, as far as I remember too. So that's another option. Yeah, woo! Converted another. Thanks for the follow as well, ZR Demons. Okay. If we slide point R up to point Q, we can make a lowercase l infinitely big. Oh. Yeah, QR is on the bottom. Yeah, there might be a problem with this question, Colded. Uh Oh wait, no, it's QP on top. No, so we're okay. I was getting the points mixed up. Because QP is in the numerator. QR is not on the plane, so we're safe there. Sorry, wait, no. QR. Yeah, okay, no. PR is the one that's that can be 0. Uh so we could just do some multivariable calculus here, can't we? Why is it? Oh yeah, no, never mind. QP, let's just get that quick. Do we need calculus? I assumed we do. To be honest, I got them backwards too, Fembox. Oh, I mean, cool. Do you want me to get a screenshot of the Desmos into here? It would help you to have that up. I can definitely do that. 25, 9, 16. 34 plus 16 is 50? The thing, I was thinking we need calculus to get the maximum. Unless we can somehow work that out geometrically, I feel like it's just going to be some arbitrary point. Because, or like, some like strange point out there. If P is not R, do we ever get the fraction as more than 1? You think P equals R might be optimal? Oh wait, Colton, you're not supposed to. Oh yeah, I remember. Colton has not done multivariable calculus. I forgot about that. Yeah, so let's avoid multivariable calculus if we can then. Um, is P equals R optimal? So P equals R does minimize the distance. Well, no. Because the smallest numerator. Is P the closest point on the plane to Q? I could believe it. No, I couldn't believe it. It means a triangle inequality? Really? Chaotic Diamond, my normal schedule is math on Tuesday, Thursday, Saturday, starting 2.5 hours ago. And then Wednesday and Friday, I'll do games. That's my normal schedule with some variance. Yeah, Maxi, I think the 2L squared. No, we are not maximizing 2L squared plus AB. Um, we are maximizing the thing in the parentheses there. Yeah, we're maximizing L. This thing is just common with Coldit's question because I think they don't just make you calculate some number involving the constants that you find, just to wrap everything up, I guess. I think it's because it's going to be like a multiple choice exam that Coldit is preparing for, and they normally do things like that to make like to prevent you from using the answers to your advantage. I think that's why that piece exists. But really the question is what choice of A and B maximize L? The triangle inequality could definitely be important though. It's a little bit difficult to think about abstractly. Let me I kind of want a screenshot like this. So I just want to like put names to the points here. Like if we were to draw it as a right triangle, this is Q and that's P. Theoretically, we could take that as a valid choice for R to give us a right triangle, whatever that happens to be. I just want to get a handle on what's the hypotenuse and what are the legs. So QR is the denominator. So that we want to be as small as possible, which would be the right triangle bit. Let's see what this is, Cruz. Hey underscore. Orthogonal projection of Q onto the plane described by R. Like finding the distance from Q to the plane? Or yeah, like basically finding the length of QR as I chose R. That gives you the right angle. But not surd. Okay. Let me take a look at Cruz's thing quick. That is a weird step, isn't it? What happens to the rest of it? What? Yeah, I didn't notice this piece go missing. The product of limits. Square root x plus 1 goes to 1. Oh. Okay, good spot, underscore. Cruz, I think your professor did the limit of just that piece there, which feels kind of cheatsy. But if you looked at just 1 over root x plus 1, you would get 1 there. And if you want, I can show that in a bit more detail. Because, oh, or unless you see it, I'll leave that alone. You got it? Okay, cool. So yeah, it does feel kind of cheesy. Can we let A and B have opposite signs, and then we just push R out to infinity along A minus A2? Make the absolute value as large as we want. Lowercase l effectively just goes to 1, becomes insignificant. Cold has calculated more of an approximation. Fair enough, demons. With this choice of R, Cold has calculated QR to be 6 plus 4 plus 4 minus 2 over root 3, which is allegedly equal to 4 root 3 for the perpendicular distance. Let's just give up. No. You think you a little too much and now you're in bed with a little pain. Oh, that's the worst, Lucas. Should take the theme song for the anime Dan to Dan and change it to Dawn to Dawn for an official channel theme song. I feel like someone's told me about that anime existing. I don't remember who. That would be funny though. It's very weird anime. Okay. Weird as far as that is saying something. Why does every horror movie dawn dawn dawn? Because I'm a scary person. So what the triangle inequality tells us, uh, QP is shorter than the sum of the legs, I think. I hope. If I remember the triangle inequality correctly. Yeah. Plus Puerto Rico. You know, Don's going to do math and it freaks them out. True. Uh, how so? That implies QP minus PR is smaller than QR. No matter where we place R. So this thing is always less than 1, I think. Oh, no, 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 no. Yes? No, no, no. I don't know if that helps us, to be honest. Because we have a minus there, but a plus here. So it's not exactly what we would want. We don't quite know how QP plus PR compares with QR, I think. Oh, nice, Mega. Because I kind of think of the triangle inequality as like almost what you wish the Pythagorean theorem was like, that if c squared, well, I mean, you probably don't wish this, but if this is true, then this is true. I think of like the triangle inequality as the correction to this logic. Um, that is equal if you're working mod 2. Oh my god. It's funny. The sophomore's dream. Is that what it's called? That's really funny. Human sophomore's dream, it doesn't involve cheerleaders. True, Mega. I this is a weird one. You definitely could multivariable calculus your way around it, around this. But I don't want to use multivariable calculus for another one of your questions, Cold. You're not supposed to use it. Oh wait, sophomore stream is a real thing? With the Wikipedia page and everything? Especially the first. What? Oh, the sophomore stream is true, unlike the freshman stream. Huh. The exam is objective anyway? Alright. There's definitely some kind of clever technique. Uh, that I'm missing here, but modified Bernoulli integral? Oh, okay. Um, to avoid confusion, I'm gonna make a function uppercase L. I have no clue, demons. It just seemed natural to consider the orthogonal projection, but I have no clue if if that is the if that gives you the maximum. I just don't know. I'm gonna make a function capital L and I'm making it capital L to denote that we're not maximizing quite yet. Hopefully it avoid confusion and not add it. QP is what we calculated before to be 5 root 2. PR is the distance formula. So 1 minus x squared plus, oops. Oh, this is going to be terrible to optimize, though. 1 minus y squared plus 0 minus 2 minus x minus y squared. This, I feel much worse about this now. We could get a numerical value at least if we use some Wolfram Alpha stuff. You got the integral down to a double sum syntax? Oh my god. And then QR. May God let my soul rest. Yeah. Okay, so in theory, this is a multivariable function. You could take the partial derivative with respect to x and with respect to y and set them equal to 0. The more I look at this, though, the more absolutely terrible that seems, and I don't want to do that. What we could do is plug it into Wolfram Alpha or Desmos and get an answer and see if we can prove this backwards. That's kind of my best idea so far, though. Like, I don't really know how to even... I don't know how to think about this quantity here. But honestly, like, QP is a constant. Can we actually wait? Can we justify this? PR. I feel like there is maybe justification for the orthogonal distance being the best one. Because if you do slide R around, like pretend that you slide it to the left, QR is increasing faster than PR. Because QR is now going like diagonal, whereas PR is just one-dimensional. And since QR is on the bottom, you don't want to increase it. You want to decrease it. No matter where you slide R, you're increasing QR faster than you're increasing PR. That might be the justification for taking the perpendicular distance. For this case, L equals 3, but how to find the point? That depends on the angles? Well, okay. You're right, I am only considering one dimension of movement. I feel like even if you consider the other dimensions, you're still okay, though. If Q is actually much closer to the plane, it might not hold. Really? Oh, yeah, yeah. Okay, maybe I can see that. If the distances are small enough. Oh wait, L is root 3 over root 2, you're saying? Um, wait, I want to see. Do the numbers that we get agree with that? Um, I'll I'll answer your question about finding the A's and B's in a second. QP we said is 5 root 2. PR, oh, we do need to name that point. Um, isn't the max of the square of the max, since square is continuous? Can you use Pythagorean theorem within the max? Uh, yeah, I mean, the maximum of the square is the same as the maximum of the regular for this. Use Pythagorean theorem within the max. I'm not sure where. P and R are both in the plane x plus y plus z equals 2. Break the distance from Q in terms of distance to that plane. Distance of the points to the orthogonal projection. We've noticed the piece about P being in the plane. Thinking about it with an orthogonal and a parallel part, we haven't talked about, though, specifically. Sort of in which you don't need to calculate L. That'd be nice. Um, two zero zero should be R by rough guess. Real cost of not rogues in the world is discrete. Oh. uh okay, let me Colton, you raise a good point where I don't know exactly how you do find R. I'm sure we can. I just don't know immediately how you do that. I'm curious to see to think about what underscore just said. Um because I think underscore is saying that if L is the maximum of this quantity, um the maximum of L squared should be at the same point, and we can say something like this. Oh, and Desmos, how do we think about this? I mean, I could put 200 on there. Okay, if I face it right at me, that looks about right. We could also get the distance between these two numbers and see if it matches. but they sure seem perpendicular. The orthogonal projection works thanks to P being on the plane. Uh, yeah, that's kind of like what I was thinking about for it. QP squared is 50. I don't quite know what to do with like the PR and the QR squared. Um, if there's only given plane, you don't have a problem be solvable. I mean, calculus could definitely help you solve it. It will be kind of complicated, but yeah, without multivariable calculus, or sorry, multivariable calculus could definitely solve it, but the answer isn't matching. Oh, okay. Uh, I think how you would probably find, like, if we want to name the point R that gives us this picture, we know a plane is defined by the normal vector, right? So the normal unit vector. We could start from Q, take the negative of the normal vector, and subtract out the distance, like multiply it by the distance. So if we rewrite the plane as 2 equals x plus y plus z, the normal vector is 1, 1, 1. Just the coefficients of x, y, and z. Not the unit normal. We should make that the unit normal vector. But if we know the distance between Q and R from the formula is 4 root 3, what we can do is start from the point Q, 6, 4, 4, and subtract out 4 root 3 times the unit normal vector. That's just the normal vector, though. The unit normal will be 1 over root 3 times. Wait, so that is 2, 0, 0, though. You're saying 2, 0, 0 doesn't give you what you need in the formula? This is 3 times 4 squared, is it not? Which is 4 root 3. So Colded, I think your answer is right. Or your answer of 2, 0, 0 is right. Because that does match. Because I'm kind of surprised I figured out this plane thing so quickly and without the help of Google. Occasionally I do something good in math. So let's just try calculating L and seeing so that means A is 2, B is 0. So QR, wait, okay, QP is 5 root 2 plus something that we need to calculate, divided by 4 root 3. We do need PR. PR is the distance from 110 to 200. One one zero two zero zero. Zero minus zero? Funny. But yeah. That is 1 plus 1 is root 2. I feel like, well, both their z coordinates are 0, right? It's the distance from 1, 1 to 2, 0, which makes sense if that's root 2. 3 root 2 over 2 root 3. This is a weirdly symmetric number, but also not quite symmetric. Or like 3 root 6 over 2 times 3. Which is root 6 over 2? We needed L squared to be fair. But what would this give us? L squared plus, or 2L squared plus AB is what we actually want. Does that equal 19? Um, 2 times 6 over 4 plus 0. Because A times B is 0. That's not 19. That's an even number. No, wait, 3? I don't think 3 is 19, last I checked. Okay, well, that's not good. It's not the orthogonal. Damn. Okay, well, there goes my logic. Back to the drawing board. I gotta use the bathroom. I'm kind of at a loss for this one now. I'm not sure. Uh, let's take a quick break though, and I'll think about it a little more. But I might not know where to go with it now. The maximum value for lowercase l occurs when we make the magnitude of PR the same as that of PQ. Make PQR isosceles. The problem disappeared from the screen after the piece. Megalomorph, it's from Colded in the YouTube chat. It is posted to the Discord in math discussion. Scroll up a bit. It's on Discord. Colded's name is Delta. Maximum value for lowercase l occurs when we make the magnitude of PR. Yeah, absolutely, Mega. DeepSeek AI actually gave you 19? Wow. So cool. I'll copy paste over what Fenbox said to you while I was on the BRB screen. Or just like said. I'm still trying to figure it out for myself. So not a right triangle, it's gotta be isosceles. I mean, that's definitely nice, demons. Magnitude of PR the same as PQ. So you're saying instead of this triangle, we want, I mean, I would need to make it bigger, but like we want that triangle where those two sides are the same. The screenshot isn't conducive to drawing that, but the maximum, the magnitude of PR is the same as PQ. I don't quite know why. Actually, orthogonally project Q onto the plane to get another point. Say S, and we found the point to be 2, 0, 0. Then let R then let R be on PS such that PR is 5 root 2, same as PQ. Huh. S is midpoint? Oh, maybe if it's an isosceles. That part I don't know, but it shouldn't matter either way, I guess. Um, I still have a hard time justifying. Oh god, I did all this work for nothing. Wait, is any of this helpful? Well, we still want. I can rebrand this to be QS. I don't know if that's helpful or not. And that is PS. Oh, I guess I. We don't need that either. Ah, that's fine. Coldest calculated R to be 3 minus 1, 0. And I don't mind checking if that works. I'm a little bit lost for why this isosceles triangle is what we want. But just don't use guessing, they use intuition. True. So that means A is 3, B is -1. Which the math still works out for that to be on R, or like a valid combination for R. L is QP, which is good old 5√2. That one never changes. Plus PR, which we need to calculate. You're saying it's 2√2? Okay, I'm just going to take your thing as fact. Oh, that makes sense if it's the midpoint, right? So we said before it was √2. QR, I guess we need the distance formula for QR. Six minus 3, 4 plus 1, 4 minus 0. Nine plus 25 plus 16. We had this before, didn't we? Yeah, 5√2. 5√2. The √2's cancel. 7/5? Sus. But let's go with it. 2L squared is 49/25. Plus 2AB? No, plus AB. And AB is -3. This isn't a whole number, much less 19. Well, why does that be subtract off 3? I shouldn't be so quick to judge. 23? No. Unless there's an error somewhere along the way. That's not right. It minimized it? Oh no. PQ equals QR equals 5√2. That's what we were investigating, yeah. QP and PR. Wait, no, did I set this up wrong? Fenlox is saying QP and PR should be the same. I did not have the same thing up here. I think S isn't the midpoint, Golden. What just happened? Because on top, by the construction, we should have 5√2 plus 5√2. Because QP is a fixed distance, right? And we choose R such that it's the same distance as QP along the direction of S, or like PS. Draw the triangle PQS. All of whose vertices are fixed. Then argue that the only way to potentially increase lowercase l The only way to potentially increase lowercase l from that position is to let s move directly away from p along a line in the plane. Call it extra distance d and get l as a function of only d. Differentiate that and set to 0. I think it was legit. Sounds like Pinbox isn't saying multivariable calculus. That's a misunderstanding. Get So you're saying you want to get this quantity with respect to basically Rs, which you call D. Which seems possible, right? Do we need, well, how? Pythagorean theorem? To increase L, we must increase PR and keep QR as small as possible. So the unique way to do that is to let point S move out along line PS and look for the sweet spot. This sounds legit. Yeah, because if you don't move along PS, you're going to be increasing QR by even more. Is what you're saying? Than otherwise? And you just happened to find that the sweet spot was the isosceles triangle. Okay, so that's helpful to know that you didn't somehow figure out it was an isosceles triangle and worked it out backwards from there. Um, so if we want to get this with like as like a single variable function, let's we want QP. I'm gonna call this uppercase L just to differentiate from maximum versus regular function. Small l is the maximum of this. So what's happening here? QP is a constant, 5 root 2. PR is that distance there, root 2, plus RS. QR, by the Pythagorean theorem, is root 5 root 2 squared, 50, plus RS squared. That's a single variable function that you can optimize. Okay. Another way to think of it, think of circles on the plane centered as S at S. On each of these circles, QR will be fixed. So the point on the circle, maximally distant from P, will be a potential point we're interested in, and all those points are on the line segment. I think I kind of follow that, but Let's see what we can do with this. I guess we got a quotient rule in our hands, but this might be this is a quotient rule that's probably worth the trouble. And I'm gonna say RS equals D just to save a little bit of writing. L prime low D high. I think I can take it home as long as if this part is good. Minus high D low. Okay, so we get a 1/2, but also a 2 from chain rule. So I think my derivative is okay for D low. And we're setting this equal to 0, so let's forget about the denominator entirely. We have basically the same thing too. Yeah, let's see. Let's multiply each side by this radical. This isn't so scary now. Maybe it's a little scary, but it's not that scary. I'm going to divide everything through by 2. Who the hell knows how this factors? 18? Minus 4 AC. This is imaginary. Did I mess up a sign? The D squareds cancel? Oh, yep. I messed up that sign right there. Thank you. Okay, that's good. Thank you both for pointing that out. Hey, listen. I got it. Thank you though. 25 root 2 over 6. Is this a good or a bad thing? Oh, no, I don't care if that looks. So that happens to me too. If I pause and unpause the stream, it'll catch back up. But like the longer I have a stream open, the more likely I am that I'm on a delay. It's really annoying. It's just Twitch being Twitch, I think. So we want to know. I want to do. This is RS that I potentially found. Let's add in PS and compare it with QP. PS is root 2. Uh, 6. 31 root 2 over 6. That's not the same. For sure, so often get the video back in my own chat. Yeah, same. I also blame Twitch. What is QP? QP is 5 root 2. Did I make another mistake somewhere? Because 31 root 2 over 6 is not 5 root 2. It's nearly 5 root 2. Did I like do the Pythagorean theorem right? QR is the hypotenuse. QS is 5 root. No, did I choose the wrong thing? I chose QP. Ah. This 50, I chose the 5 root 2. I think I meant to choose 4 root 3. 48. That's why I was just slightly off. Eight. 48 divided by 6. 8? Four root 2? Hey, that's what we want, right? Because that's 5 root 2. Nice. So I get isosceles. Okay, so we know the length of PR now. Let's figure out where PR is. So let's get the vector from P to S, I think is what we have to do. Make it a unit vector and scale it by that distance. I think that's what we want. So SP is root 2 in length. The vector S is at 2, 0, 0. We proved that before. P is 1, 1, 0. So the vector from P to S is 1, 1, 0 minus 2, 0, 0. Minus 1. I already... Ugh. S... You do S minus P. No? Yes. How does that work? Yeah, S minus P. Yeah, okay. S minus P. My brain is starting to crash, apparently. So 2 minus 1 is positive 1. 0 minus 1 is negative 1, and that's 0. And that makes sense, because I should really just think about it as an x and y plane. One is at 2, 0, 0. The other one is at 1, 1. From here to here. Right one, down one. Perfect. Okay. Or how do you... I don't remember how you... What's the notation for... Oh, PS hat will be a unit vector. 1 over root 2 minus 1 over root 2. Yeah, Papadoria, we're almost there. Fenbox had a really important realization, so we can definitely solve the problem now. Okay, so now we start at point P, which is 1, 1, 0. Plus the length we want times the direction we want, the unit direction that we want. And that'll give us our point R. Ugh. 1, 1, 0 plus 5 minus 5, 0. 6 minus 4, 0. Okay. We have the pieces of the puzzle. L. We said the numerator is both 5 root 2, right? The denominator is QR, which we do need to calculate. We know QS and SR though. Uh, 4 root 2 squared, 32 plus QS squared is 4 root 3. 48. Please work. $80? Where 80? 16 times 5? Another weirdly symmetric number. We only care about the square of this thing. I'm not going to bother rationalizing it. Okay, 5 root 2 squared is 50. 2 root 5 squared is 20. Plus a times b. A is 6. B is minus 4. We get 5 minus 24 is 19. Oh my god. Oh, finally. This is a crazy problem, Colton. $19 is apparently the answer that Colton gave at the very start. The grand resting of dawn, yeah. Find a nice way to solve it? I don't know. Bode, I don't expect anyone to solve it or waste their time on it, but I'm too stubborn to read the hints and I need some help, at least vague hints. Oh my gosh. Bode was a problem. I want to look at um Papadoria, you've been very patient. Do you want to talk about your problem? BB did, or there are 2 questions now on the Discord. But Papadori is actually here right now. Well, Bode might also be here, but I feel like I'm not going to know Bode's problem. I haven't looked at it, to be fair, but I like to, since Papadori has been here since the beginning, I want to talk about a problem. I'd like to get to Papadori. Yes, I can absolutely screenshot this. Yeah, Chaotic Diamond. It was very difficult. Possible though. There's one screenshot. There's another screenshot. Twitch does have a character limit too. I think it's more than YouTube though. Yeah, a nice way of solving this. I'm not gonna bother, but there probably is a nicer way than what we did. like some kind of geometric realization you can make about why it must be isosceles. Hell if I know though. My neck is sore from like being tense and hunched over when solving that one. I need to sit up straight. Um, Bode was just here. I almost certainly can't contribute anything to it, but it's a nice word from IMO problem 6. An axis of symmetry? Maybe, I don't know. Is it actually an IMO problem? Well, let's see Papadoria's question. I will bring up both questions because I'm not optimistic I'll be able to actually do anything with it, but let's at least read it. Bode does some very difficult math, so I don't expect to be able to say much about it, but just so we have something to do while we wait here. Uh, yeah, sure, Colton. It's from Bode who posted in Discord too. Let me I'll ping Bode and ask him to I pinged you in the thread where it's posted in case you just want to see for yourself. Posted around 2014. Not exactly sure though. Okay, and you found it. Uh, Mixed to linear? I didn't even get that far in the problem. A mixed to linear? Oh my god. Yeah, I feel like I can't. I don't even know what that means. Okay, and then I see that you posted it, Papadoria. Let me read what Megacycus is related to this last problem it looks like. For a fixed value of QR, maximizing quantity maximizing PR, but the points where QR is fixed as a circle on the plane x plus y plus z equals 2. I have to have that P, Q prime, R line on a straight line. Where Q prime is the orthogonal projection. Okay, what we called S. Maybe the first step of getting is isosceles. Interesting. I'll paste it over to Colded in the YouTube chat in pieces. because YouTube has like a character limit of 2. It feels like. Okay, so let's look at Piggy Master / Papadoria. Yeah, I'm sorry, Boat. I at least read it, but like like usual, I just feel a little like lost with it. Hey, welcome in, Master of Texas or Master O Texas. I do it because I like it. It's a pretty neat community of people who like math around here on Twitch. Not just in my channel, but also in the other math streamers channels. I have a bachelor's in math for background, and I did that, and I chose it because I enjoy it. Definitely not to make money. That sure hasn't happened. A non-piecewise function s of x that sums the digits of x to the left of the decimal? Oh no. Never liked math, but I was always good at it. I was just scrolling down and saw math as a channel, couldn't believe it. Just became an actuary. All my friends became man. I don't know, man. Being an actuary just doesn't seem appealing to me. Version BB posted is quite nice. I briefly skimmed it. I was a little. I felt nervous that I wouldn't understand it. Oh, I see you posted something though. Thank you for doing that, Bode. Because I looked and was like, ew, that seems a little hard. Cole, what is the question? I was just reading this one to see if I could even understand it. The answer is no, or at least it'll take me a lot of thinking. The question that I'm going to think more about right now is this one down here. Yeah, I mean, I don't know if it's a thing that you'd enjoy watching, Master of Texas, but in case you are, I'm not the only person who does stream math, and whenever I see a new face, I do like to let people know that I'm not the only one out there. But you say you're not a fan of math, so I'm not like forcing anything on you, but I just like to let people know. What is Q prime? Oh, Q prime. I'm sorry. Q prime is what we call the S. It's like that orthogonal point. Twitch chat is very delayed on your side. Oh, I'm sorry, Papadoria. Math reading the algorithm now. Yeah, I mean it's a small niche, but you might get some of them in the algorithm now. Just looking at numbers, you have to check people's work, and then people check your work. Yeah. That sums the digits of x to the left of the decimal. The first two actuary exams and did well in them. Just gonna imagine working office all week long. I mean, I've worked the office life. I think I'd rather do administrative stuff than do. I think I'd rather go back to administrative stuff than doing actuarial work, though. Sums the digits of x to the left of the decimal. Like it feels. But I need a table. It feels like it should be linear. Oh wait. Oh no, log 10 is the length. Yeah. Okay. Yeah, log should probably be involved somewhere for the actual function. The working from home part does seem nice. Um, no, to be honest, Cold, I was just kind of I didn't read it that closely for myself. Uh, sorry, I'm the more like what Megalomorph said about this problem, the more I'm getting confused for myself now. I think what he's saying. Sorry, this is about the previous problem. Um, you have some chaos. Yeah, sorry, because I copy pasted what you said over to the YouTube chat without reading it too closely, but now I realize that Colton doesn't understand it, and actually I don't understand it either, or like why this means it's isosceles. Um, maximize the points where QR is fixed. I haven't drawn R on this, but like they're talking about the distance from say the point R there to Q, the blue dot. You can choose any of them in a circle that has the same distance. Uh, but you want to. Oh, you don't have a full argument that it's being isosceles. Oh, I thought that was getting isosceles. Okay. So Colton, I misunderstood the point of this. This isn't a full proof of it being isosceles. It would just be part of a proof. We want QR to be small and PR to be big. QR to be small and PR to be big. Um, I think what the for any like fixed distance QR, you can draw a circle that my circle is lopsided. That represents every possible like choice of R, and the choice of R that gets you your optimal maximum is directly across. To show this is to show they're all in a line at least, and that point is S or Q prime. But yeah, that's not the entire argument apparently. So sorry for like not saying that right. Okay, so Papadoria, you're saying x over 10 to the ceiling log base 10 of x minus n. No, the ceiling does not include. This thing puts the nth digit in the ones place. Wait, so what's the actual definition for S then? Because I'm still kind of lost on that. This seems like a piece of the puzzle. You're asking particularly about part B and D. Check out the Desmos link. Oh, I completely missed that. Uh, Part A is all you really need help with, at least you hope. Part C, I've already proved the limit non-existing. Part B should come naturally in D as well. Where did you put that link? I don't see it. Oh, if you put it in the YouTube chat, YouTube might have censored it. If you put it in the Twitch chat, it'll show up. But yeah, on YouTube, I think you can't put links, unfortunately. And one day on Twitch, I'll have to turn off links too, I'm sure. But I'm waiting until people abuse it more. Ooh. Okay. Yeah, that seems like that seems about right. So I remember Anders a long time ago giving me an integral that kind of felt like this, involving ceilings. Set I to be anything, or L to be anything, and it sums the digits. Okay. This is a more complicated version, though. Do these repeat exactly? I don't think so. The limit doesn't exist for n going to infinity. Well, we only care about 0 to 100? Ooh, we only care about 0 to 100. That's good. We don't have to worry about weird end behavior or like anything like that. This feels like there's a geometric way of thinking about this. Because every multiple of 10 we reset. I would not try to actually integrate this. I would my thinking is that we need to add up these rectangles geometrically. That's still not an easy task, but like even just considering 0 through 10, that's pretty easy to just get the area. Got 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Yeah, I think this is a geometry problem. So let's think about the integral from 0 to 10 of s of x. That's, the width is all 1, importantly. So we can say it's just 0 plus 1 plus 2 plus 3. Ooh. Not 10 exactly. Like, can I say 9.99 and no one's going to be a smart aleck and say that that's actually 10? Like, I think we break it up into pieces like this, though. That's my instinct. Isn't that 45? There's supposed to be an 8 in there, too. And now we go 10 to, like, 19.9. And I have the same request. And I think the only difference is that it's going to be the same sum, but everything gets plus 1. I think. Because, yeah, our first one is now 10, which becomes 1. I think it's plus 1 every time. Because then 11 is 2. 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 55, it should be. Because we added 1 10 many times. But I think that's just the technique right there. It's going to be... Can we spot the pattern now? N equals 1 through 10, maybe. Geometric reasoning suffice for the integral from 0 to n? I think so. I think we can write this as an arbitrary like formula. Because I think the important thing is just we have breakpoints every multiple of 10. 45 plus, well, 0. Nx, is that? This, I probably need to modify this, so let's not, it's probably, let's be exact about this. The from 0, let's say that's n, and this is k. S of x dx is equal to the sum from k equals 0 to, I want to say n over 10, and maybe floor it minus 1. I'm not quite sure for like any n, but for the nice clean number like 100, I think we go up to 99. The number of digits increases, that's the only time we go back down to 0. Ooh. This might not, no, yeah, this might only be valid for 2-digit numbers. And we probably shouldn't get so complicated. Yeah, for an arbitrary n, I'd have to look at the patterns like this, but for 0, yeah, exactly. We get a new maximum for every like all 9 number. Is this right? To 9? We need 100 exactly. No, for an integral, 100 itself doesn't matter. Okay, so let's from 90 to 99.9. Nine plus 10 plus 11 plus 12, 13, 14, 15, 16, 17. It should go up to 18 because of 99. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the same thing as we added 9 10 many times to the original thing. Yeah. So I feel confident then that if you add all of these up, you get 45 times 9 plus 10 times 45. Whatever that is. 45 times 19. Eight 855? You might have made a mistake. You have an arm using law of sines that the triangle PQR should have a right angle at Q. No, it's an isosceles right triangle. Or sorry, it's an isosceles triangle. And it's not an isosceles right triangle. Because the calculus way that Fenbox found didn't rely on any geometry facts, like, or like we weren't we found out at the end that it's isosceles, but we weren't relying on like geometry facts like that. Trying to avoid, yeah, that's fair, but I think we know the answer is that it's not a right triangle. It's isosceles and Q isn't the apex angle, so it can't be. So yeah, Papadori, I'm pretty sure 855 is the answer. I feel pretty good about it. I don't know if that sits right with you, but 0 to 100 is simple enough. That I think we don't need anything too special. Oh no, we need the integral from 0 to n. Ah. I didn't read part D. We do have to investigate what happens once we hit the 3 digits. Okay, let's just keep doing what we were doing then. You do feel good about that part B answer? Okay, I'm glad. So do we want to go up to 109, I guess? One plus 2 plus 3 plus 4. Okay, yeah. We'll go up to plus 9. No. Yeah, no, we're going up to 10. So now we're starting with that case. We skip all the way to the end now of the hundreds. We probably need another log is the answer. Or like we need because there's going to be another tricky breakpoint every power of 10 where a formula is going to have to change. So there's going to need to be a log base 10 somewhere in here. Oh, you want to look at actually integrating this thing? I mean, we can look at that. Yeah, I've seen integrals of floor functions like that too, where you can do some trickery to make it a summation. Floor x times 10 to the n over 10 to the ceiling log mod 10. That's our definition of S of x that we would, in theory, like to integrate. And you're noticing that, or you're saying that, x mod 10 is equal to x minus 10 floor x over 10. I think I can see that, yeah. So that at least gets rid of the mod. That's progress. Are we able to switch sigma and integral here? Hmm. I would feel sketchy about that because the summation involves x. And we're integrating with respect to x. Maybe it's still justifiable, but I'm not sure. This is such an annoying integral. Hmm. Just assume we can switch and then split the integral into two by the minus sign. Yeah, just for the sake of argument, let's explore that. And put a question mark to mark that this is a potentially dubious step here. I might almost rather write this as x 10 to the n minus. That's a weird ceiling. I mean, oh, I was about to say this basically amounts to the integral of the floor function of x times a constant, but it's not a constant. There's an x in the exponent as well. Oh, oh. What does this actually mean geometrically, though? But I think no matter what, we do have to we do have to use the geometry to our consider or to our advantage in some way if we want to integrate the floor function. Um, I think the trick here that you would normally do with a floor function is split it up based on ranges of n, and you would end up with a double summation. Grandma Don, do you have some cookies? No, I wish I had some cookies. They sound really good. Tomorrow, I am going to buy the ingredients for some lemon cookies, though, so I can hand them out to my many grandkids. Definitely not scarf them down for myself. So I guess like from the one integral involving four functions I've done before, I think the biggest realization you make is that you can give yourself an easier problem. It might be easier to do it at this part in one integral. Uh, what am I doing? It will be a double summation. I guess we'd split it up based on powers of 10 or something, maybe multiples of 10. But each individual integral is a lot easier to calculate. It will be some close, like you could make some formula like I did up here. I don't know. Let me find the recipe. I have it bookmarked. I tend to use a lot of this website's baking recipes. Crisp and chewy. I guess soft then. But yeah. Oh. No. Double summation is fine as long as we have a closed expression in terms of n and x. I'm trying to remember how it works, but like if you had just the integral of floor of x, one of the first things you would do is split it into many different integrals. And I just don't remember how that works. That's what I'm trying to remember. I equals 0 to something that I'm not sure of yet. Of the integral from I. This is the part where I'm getting stuck on. But like, you want to split up into intervals that are easy to integrate over, is the point. I just can't remember how this works. And finding intervals that are convenient here is a little bit harder. But it would not get rid of the integrals. It would just be a first step, basically. Thanks for hanging out, Laylee. See you around. Oh, you have to go, Papadoria? All right. Sorry I couldn't help you out more with this part, but thanks for the question. My brain is kind of crashing. Uh, I might call it here too. I don't think anyone else is waiting on me. I sure hope not, because I completely forgot about it, but I don't think so. Yeah, like Cold I took care of. BB I probably can't do, so and I see Bodo's working on it. Uh all right. Yeah, I think we'll wrap things up here for the day. So I don't mean to cut up a conversation, Fenbox and Mega. It is still posted in the Discord if you all want to talk about it more. But my brain is telling me that it's time. I still haven't finished that E&M problem. Ugh. Okay. I'm gonna cut you off here. So news here on YouTube. Thanks for being here. Back on YouTube on Tuesday, probably.